This video is for standard algorithm of multiplication. That is multiplication of whole digit, multi-digit whole numbers. So I'm going to start small with 12 times 12 just to show how standard algorithm works, and then I can show a bigger number. So 12 times 12, what multiplication is saying is 12 times. So if you had 4 times 3, it would be 4 3 times, or 3 4 times, depending on how you read it. I know that elementary people are really big on consistency, and the standards for elementary is really big on consistency. I read it both ways because, you know, it is commutative, but 4 3 times, 12 times. So that's what I did here. I did 12 boxes, 12 boxes, 12 boxes, and I drew it 12 times. So if I'm correct, if I drew it correctly, this should be 144 boxes right here. So standard algorithm calls for you to start in the ones place. You have a base number. It's easier if the number on the bottom is the smallest number. In this case, it's the same number, so it doesn't really matter. You start at the ones place and you multiply this digit by every digit on top. We only have 2 here, but if you had more, you would just keep going, every number. So I'm going to go ahead and do that. 2 times 2, that gives you 4. 2 times 1 gives me 2, so I have 24. Now I have 1 times 2. You scoot over 1. Standard algorithm, you scoot over 1. You put a 0 as your placeholder. 1 times 2 gives me 2. 1 times 1 gives me 1. So I have 144 when I add these up. How does this work? The answer is always place value. This works because of place value. So instead of drawing this huge picture all at once, standard algorithm just breaks it down. That's all it does. 2 times 2. I'm going to go ahead and draw it. 2 times 2. Then it moves to 2 times 10. This is not 1. Right here. 1 is the digit by itself. The place that it's in is the tens place. So this is a 10. 2 times 10. Backwards. Doesn't really matter, but for sake of room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is 2 times 10. So we know that this is 1, 2, 3, 4. And this is 20. I would count them, but we know it's 20. Okay, so now we do it again. 1 times 2. Is this 1 times 2? No, it's 10 times 2 because of place value. It's in the tens place. 10 times 2, so we're going to do the exact same thing again. Just pretend these are the same size, I guess. 2 and 10. Alright, and the next one that we have is 1 times 1 is the last one we're going to do. But again, it's not 1 times 1. These are in the tens place, so this is actually 10 times 10. And I would draw that out, but it's going to take forever, so I'm just going to do this. 10 times 10. So if I were to draw this out, and we were to count them, like that, we would know that this is 100. 100 little squares in there. So standard algorithm breaks it up by place value. Even if you don't realize that's what you're doing, that is what you're doing while you do it. And then this piece right here, they're just adding these together. 120, 120, plus 20 is 140, plus the 4 is 144. This is why this works. Why do you move over 1? Because of place value. You start in the tens because that's where you started up here. You start in the ones right here because that's where you started right here. Maybe I should erase this to show you a little bit more better. You're not just moving over a place. You're starting with this 2 first. You're saying 2 times 2. That's why you drop the 4 in the ones place. When you move over to this 1, you're no longer in the ones place. It's saying 10 times 2, not 1 times 2, 10 times 2. So you're not just putting a 0 and then saying this is 2. 10 times 2 is 20. And then 1 times 1, it's 10 times 10, it's 100. So you're going to drop the 1 there, but it's in the hundreds place. So you just wrote 100 there. So technically, if we were to work this out, standard algorithm is kind of a shortcut. So 2 times 2 gives us 4. We're in the ones place. That's correct. 2 times 10, though, that is 20. So we're going to write it out here. This is why, this works. Because essentially you're actually adding these together. You're just skipping the step in the standard algorithm. So you're saying this is 24. And you're just skipping this entire step. So this is one of those Common Core ways that teachers are teaching. They're teaching this extra step. And they're doing it so that their kids can understand the concept of what they're doing and not just recognizing procedure. This step, yes, it can be skipped. But it's important to know what you're doing. Why does that 24 just go there? So now we're going to move on to the tens place. 10 times 2 is 20. Now we have 10 times 10. That is 100. Place value. This is why you scoot over. Teach your kids that, please. Don't put a smiley face there. I hate that so much. So yeah, you're just adding it. So this step could also be skipped, but that's why it works. This isn't an arrow. This isn't a skipped place. It's not just moved over and it's 12. It is a 0. It's because this is place value. So I'm going to do another one. And I don't need this anymore. So let's do, I don't know, 423 times 47. Okay, standard algorithm. I'm going to do standard algorithm first. And then I'm going to show you all the skip steps over here. So 7 times 3 is 21. So you have to drop the 1, carry the 2. 7 times 2. That's 14, 15, 16. Carry that 1. 7 times 4 is 28. 29. Alright. So now, I hate this. This is a pet peeve of mine when teachers teach their kids to put a smiley face there as a placeholder and then move over. Instead of teaching them to just remember to put a smiley face there or a cute little way, tell them why it's there, okay? It's a 0, not a smiley face. So we're scooting over. We're done with this 7. We're scooting over to the 4. This isn't a 4, it's a 40. So we have 4 times 3, we get 12. Maybe I should have done it in a different color. I think I will. Sorry, backtrack. Okay, where was I? 4 times 3 is 12. Don't put a smiley face, it's a 0. Said that. 4 times 2. Sorry. 4 times 2 is 8, 9. 4 times 4 is 16. Alright, so there's my 2 steps. I'm going to add them together. Sorry. Okay, so now we're going to add them together. We have 1, 8, 9 and 9 is 18. Carry that 1, 6, 7, 8, 9. And the 1 comes down. So we have 19,881. So now I'm going to show all those skipped steps from standard algorithm over here. So I have 423 times 47. So we're going to start with the ones place. So blue is going to be ones. So 7 times 3, that's correct. We have 21. 7 times 20, not 2. 7 times 20 is 140. Now we have 7 times 4 or 7 times 400. So we know 7 times 4 is 28. So 7 times 400 is 2800. So there's my ones place. Now we're going to move on to the tens place. 4 or 40 times 3 is 12. So 40 times 3 would be 120. 40 times 20 is 80. I'm sorry, not 80. 4 times 2 is 8. 40 times 20 is 800. And then 4 times 4 is 16. And we know that 400 times 40 gives you 1600. Okay, 16,000. So here's my tens. This was when we multiplied the 4 in the tens place by every number up here. And this right here is when we multiplied the ones by every number up here. So as you can see, if I were to write this out, for the ones we would get 2961, just like we got here. For the tens place, if I were to have added these, just these, I would get 16,920, just like we got right here. And now, if I add all of these together, I have 1, 8, 9 and 9 is 18. Am I lining this up? Sorry, I'm looking at it sideways. 9, and then the 1. So we received the same answer both ways. And I know this is actually an invented strategy as well. It is a longer way to get to the same destination, but this way shows the actual concept and it shows the actual place value of what you're doing. Rather than teaching them just 4 times 3, 4 times 2, 4 times 4. This is actually showing them it's 40 times 3, 40 times 20, 40 times 400. And that's why the standard algorithm works. So this way, you're not carrying that 1. You're not just teaching them that this is a smiley face placeholder. My teacher, I think when I originally learned it, told us to put an arrow there to help us remember to scoot it over. I would just prefer that someone would have taught me that a 0 goes there. Because I seriously just memorized procedure instead of understanding why it works and what I'm doing. So this way, the place value, showing the actual place value is an excellent way to actually teach multiplication, and you can also use visuals to assist in that as well.